All right, we're section 3.6. This is the last section of this chapter. So guess what's coming up soon? Wow, you guys are quick. All right, how's that look? Quick. All right, here we go. Let's do this. Let's talk about. Let's draw a line like this, and draw a line. Oops. I always forget to change this thing. Done this enough, you'd think I'd remember. Okay, let's try this again. Ready? We're off to a little rough start. It's a rainy day. I'll blame it on the rainy day. There we go. Are you ready? What are those? What does it look like is true about those two lines? Yeah, they cross each other. That's true. Yeah, they intersect each other. What if I did that? What are they? It's a right angle, perpendicular. Okay, the lines are perpendicular. Okay, that's what we're going to talk about. All right, are you with me on that? So we know what perpendicular means. We know that two lines that intersect at a right angle are perpendicular. What if I did this? So I just did that just to remind us what perpendicular is. Watch this. What if I put a point like right here, and I asked you, what is the distance between this point and this line? And I asked you to draw it, okay? To draw the distance from this point to this line right here. Well, where would I draw it? I would start from the point, right? And I got to hit the line somewhere. Where do I hit it? Do I hit it right here?
Anywhere.
Do I hit it right there?
Anywhere.
Anywhere?
In the middle.
Look at that line. If I hit it anywhere, what's happening to that line? It's changing what? Changing length, isn't it? So there's not just one length. If I just go from here and hit anywhere on this line right here, it's not the same length, is it? All right, because look, as I go like this, the length continues to change, right? It gets smaller and smaller, and then it gets bigger and bigger and bigger. So I got to decide where on this line am I going to hit in order to just get one length, so that we're on the same page and we make sure that we just talk about one length or one distance. If I talk about the distance from this point to this line, where do you think I'm going to hit? Am I going to hit it here? Am I going to hit it at the end point? Am I going to hit it at the other end point? Where do you think? In the middle. So I hit the midpoint. That looks about midpoint. Is that the distance that I'm going to do?
Yeah. No. I don't know.
What if this was a line? What if it was a line and it kept on going and going? There's no middle to it, is there? All right? Kind of every point would be in the middle, wouldn't it? Because it's just the same distance from one end to the other end. So it's not going to be the middle of this line right here. What do you think? What did we just talk about? Think about what I warmed you up with and we talked about. Say it, Ben. Okay. Midpoint is the middle. So we already said it wouldn't be in the middle. Okay, so midpoint would not be a correct answer because we've already established that it's not going to hit it in the middle. Ben said it. Say it louder, Ben. It's going to be what? Perpendicular. That's it. Remember we just gave a little two lines right there. We talked about being perpendicular. Don't you think that's going to enter into what I was going to say next? See, I'm trying to lead you up to it. I'm not trying to just take things out of the, just random stuff, okay? I'm trying to lead you up. Do you see where I was going with that at the beginning? Talked about lines that were perpendicular? Right. Okay, so if I start at this point right here and I said, what is the distance or what is the length? Let's use the word distance. What is the distance from this point to this line right here? Where would it be? Would it be from here to here? There? Would it be in the middle? Would it be to there? No, it would be what? It would be perpendicular to this line right there. So if I talked about the length of this line or the distance between this point and this line, we'll call this point P and we'll call this line L. All right? If I said draw the distance between point P and line L, how would you draw it? Would you just draw it anywhere connecting the two? No, because you saw that those distances changed, didn't they? All right, so we've got to be consistent and get the same distance, and where would it be? It would be perpendicular. It would be a line drawn perpendicular to the other line. So if I have a point outside a line, and I ask you to find the distance between that point and that line, we would draw a line that's perpendicular. All right, Jaden, put that away. This is not lunchroom. Put it away. There's no snacks in here. You can drink water, but there's no eating snacks. And all the crinkling of the papers, just making it even worse. Thank you. All right, you understand what I'm saying here? So if I have a point and I have a line, and I want to find the distance between that particular point and that particular line, I draw a line that's what? That's perpendicular to that line right there. Does it make any sense? Yes? No? Maybe? I thought I explained that. Okay. Doesn't look like it. Looking into your eyes, doesn't look like you're understanding what I'm talking about. Is it the rain? Is that what it is? Look, what if I had a point right here? Okay? We'll call it point A. And we'll call this line, I don't know, M. Alright? There's a line like this. Basically, I'm just repeating what I said earlier, because sometimes just repeating the same thing, for some reason it clicks. Alright? So I'm going to say it again. If I wanted to find the distance from this point to this line, and I asked you to draw it, draw the distance from this point to this line, we would start from the point, and where would we draw the line? Would we draw it here to the middle? Okay, let's not say straight down. Perpendicular. Okay, we never said straight, did we? Okay, this is straight, isn't it? That's a straight line. That's a straight line, but that's not the distance. Okay, so we don't say straight down. I know what you mean. I understand, you know, what you're talking about, but let's use the vocabulary that we've been using. So it's from the point where to the line? Perpendicular to the line, right there. Okay, that is the distance between this point and this line M right here. Everybody with me on that?
Yeah.
Okay, let's take this a step further. What if we had two parallel lines? One's like this. I'll just copy and paste it so it's the same. Oops. Oh, come on, grab it. Where are you? Come on. Why am I? There it goes. Alright, there's two parallel lines right there. You with me? Alright, I just copied and pasted so you know that they're parallel. What if I ask you to find the distance between those two lines? That's right. So if I find the distance between this line and this line, would it be from there to there? Is that the distance between the two lines? Is it from one endpoint to the other endpoint? No, because they're technically lines. Do they really even have endpoints? No, they don't. Alright, so what would it be? It would be from any point on this line. Whoops. It would be any point on this line. What do you think? Say it. Perpendicular to the other line. That's right. Okay, that would be the distance between the two lines. You with me? So if I have two lines, line L and line M, and we had you could pick any point on this line. It doesn't make any difference. Okay, pick any point on the line. If I want to find the distance between the two lines, I'm going to go from here. See, this is why I don't say straight down. Because if I said straight down before, what would straight down mean to you? It would mean like that, wouldn't it?
Yeah.
That's kind of straight down. So we don't say straight down. What do we say? We say perpendicular to the other line. Does that make sense?
Yep.
Alright, so that would be the distance between the two lines. I'm repeating myself. I'm taking this very, very slow so that you understand what I mean to find the distance between two lines. Do you think we covered it okay there? Alright, let's do this. Let's pause this for a second. Let me set something up here with some graphs and things like that. And then we're going to actually do some real math here. We're going to actually put some numbers in and all that stuff. That was all just theory. It was just trying to get a general idea, wrap our mind around what the distance between a point and a line is, what the distance between two parallel lines is. Okay, that's what we're trying to do. I don't know, I just thought of this. What if you had a line like this and a line like this? And I said find the distance between the two lines. Is there one distance between those two lines? There's really not. Okay, so if the lines are not parallel, because look, if I went from here to here, that would be a different distance than from here to here, wouldn't it? And if you say, well, go perpendicular, you said go perpendicular. Well, look, that perpendicular distance would be different from that perpendicular distance. So is there truly one distance between two non-parallel lines? No, there's not. So we can't really say that. So we only talk about the distance between two parallel lines. Make sense? All right, because that'll be consistent throughout. All right, let's pause this and we'll write something down. Okay, here's the problem. It says line L contains points -5, 3. So let's plot this on our graph right here. -5, 3. So it's 1, 2, 3, 4, 5. 1, 2, 3. Make sure I'm counting right. And 4, -6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Right there. All right, so that's line L. Let's connect them to make the line. Go from here to here. Alright, So there's line L. Now it says find the distance between this line and this point 2, 4. So let's plot the point 2, 4. 1, 2, 1, 2, 3, 4 right here. Now do you see what we're doing? Here's a point, here's a line. What are we trying to do? We're trying to find the what? The distance. So let's draw it. Let's put this in a different color just to make it stand out. Let's, I don't know, let's go this blue color. Okay? So watch. I want to find the distance between this point and that line. So I want to sketch it out. Now it might not land perfectly, but where should it go? Should it go to this endpoint? Is that the distance? Should it go to that endpoint? Is that the distance? What did we just finish talking about? It's going to do what? Say it. It's going to be perpendicular, right? It's going to be perpendicular. And it's kind of looking like it's going to hit right there, doesn't it? And I just want to see if it is. Yeah, I believe it is. That looks perpendicular, doesn't it? So it's going to hit about right there. Now, you can't just go by the graph, because sometimes it doesn't land perfectly right on a point. All right, so it kind of looks like it does here. All right, it's an example. They usually make it a little bit easier for us. But you can't just rely on that. What we have to do, we've got to do some math to make sure that it actually does land right here. So what we're going to do is find the distance of this blue line. I'm trying to find the length of that blue line. Well, what do I know already? I know that this is, let's put this in, just put this in black. I know this point right here. What is that point? It's 2, 4, isn't it? Okay. Now, I think I might know where that point is, but I can't just look at the graph and just guess, just because I just kind of eyeballed that being perpendicular, didn't I? All right. I mean, I didn't really, do anything in particular. I just drew it. I said that looks perpendicular, so I made it. So I can't be positive that that's my point right there, but I do know this point, which is -5, 3, and I do know this point down here at the bottom, which is 4, -6. So what do I need to do? I need to find the distance from here to here. Well, it's a line, and I got points. So what do we use to find the distance? Distance formula. Okay, but the problem is the distance formula means I need 2 points, right? Well, I got one here. Problem is, I'm not sure what that point is. Now, I could kind of guess and kind of figure where that point's going to be. It looks like it's -2, 0, doesn't it? But I can't be assured that it's -2, 0. I can't be positive because it's not always going to land right on a point like this. Okay? Now, it may be that point exactly, but I got to make sure I know where that point is. Now, to find that point, you got to go through a little bit. So what we're going to do is this. I'm not going to explain why, but I will explain what we're going to do. First thing we're going to do is we're going to find the equation of both of these lines right here. Okay? We're going to find the equation of these two lines. So let's do the red line first and figure out what the equation of that line is. Well, what do I know? I know 2 points, don't I? We did this stuff in another lesson not too long ago, just probably 2 or 3 lessons ago. Found the equation of a line given 2 points. What do we do to find the equation of this line? First thing we do is find the slope of the line. I'm going to go through this kind of quick. You can always go back and look at it. The slope of the line is the change in y over the change in x. So it's going to be 3 minus -6, which is 3 plus 6. And then it's going to be what? -5 minus 4. So what is that? That's 9 over -9. What's 9 over -9? It's -1. So the slope of that red line is -1. Everybody with me so far? Let's find the y-intercept. Well, I'm going to write y equals mx plus b. I know the slope, and I know an x and a y. Where do I find an x and a y? Either from this point or from this point. It doesn't matter. Let's just use the first one. So the y would be 3 equals the slope, I just found it, which would be -1, times x, which would be -5 plus b. Now let's solve for b. Now we could kind of look at it and figure out where it should be, but we want to make sure that the numbers work out, because we don't know, we can't just trust our graph on this. It's just a guideline. So that's what? 5 plus b, subtract 5. What is b? It's -2. And sure is, isn't it? So my graph was fairly accurate. Now if you just sketch stuff out, it may not be that accurate. On mine it was pretty good. So what's the equation of that red line then? In fact, let's put it in red. And I only have a few more seconds here. But what is the... Oops, that's not red. That's okay. Y equals what? -1x minus 2. That's the equation of the red line. Everybody with me so far? Alright, let's pause this and we'll go to the next video.